Hello, discrete math fans. Let's talk about rational numbers. So a real number r is called rational if and only if it can be expressed as a quotient of two integers, as long as the denominator is non-zero. We're never going to divide by 0. If you divide by 0, you write that on your paper will burst into flames. Any real number that is not rational is called irrational. Now let's take these numbers. Let's determine if they are rational or irrational. 13 over 4, 2 over 0, negative 7, 0, 2.913, and then the last one is 0.242424, so on. The 24 repeats forever. All right, 13 over 4, that's rational because it's a quotient of integers. 2 over 0 is not even a real number, since in the real numbers we can't divide by 0. So we're going to say that 2 over 0 is not in the rationals. Negative 7. We can write that as negative 7 divided by 1, so that's rational. 0. We could write that as 0 over 42. That's a quotient of integers, so that's rational. 2.913, we could rewrite that as 2,913 divided by 1,000, so that's rational. So with that idea, any terminating decimal is rational. All right, for the one with the 0.24 repeating, we're going to use some calculus. This is going to be one of the very rare times in this class when we want to use some calculus. Now we're going to think of a repeating decimal as an infinite series. So you can see that 0.24 repeating, you can see the little bar above the 0.24, that means that piece is going to be repeating. So that's 0.24 plus 0.0024 plus 0.00024, and so on. So we can think of this as 0.24 plus 0.24 times 0.01 plus 0.24 times 0.01 squared plus 0.24 times 0.01 cubed. So this is a geometric series. The first term is a equals 0.24 and the common ratio is 0.01. Remember that a geometric series is an infinite series where we get from one term to the next by multiplying by a fixed common ratio. We have a theorem in calculus that says a geometric series converges if and only if the ratio r satisfies absolute value of r less than 1. So that does happen in this case. And when it converges, it has a sum of a over 1 minus r, a being the first term. So we can say that the sum of the series is s equals 0.24 over 1 minus 0.01. That's equal to 0.24 over 0.99. And now we can rewrite this as 24 over 99. If we like, we can simplify it into lowest terms as 8 over 33. And so that is a rational number. This general method can be used to show that any repeating decimal, even if the repeating portion doesn't start at the very beginning of the number, right after the decimal point, any number that's at least eventually repeating can be written as a fraction. And we're actually going to give a proof of this later on. We'll carefully write out the proof of how we prove this. But for now, this is the general method that we can use to write infinite repeating decimals as rational numbers. Okay, that's all for now.